Chapter 10.4, we have inscribed angles, and an inscribed angle is an angle whose vertex is on a circle and whose sides are chords of the circle. So in this case here, we have E is the vertex of the inscribed angle. It's on the circle, and ED is a chord and EF is a chord. In circle G, minor arc DF, this is the minor arc DF, is the intercepted arc. Okay, and so we have a theorem here for the inscribed angle. If the angle is inscribed in the circle, then the measure of the angle is equal to 1/2 the measure of its intercepted arc. So in this case here, angle DEF is equal to 1/2 the measure of TF. And we can use this to solve problems like this one here. So circle G, we have the measure of DF is equal to 90 degrees. So this arc DF is 90 degrees. Then we're going to go ahead and find the measure of angle DEF. Well, we have our equation here. So it's measure of angle DEF is equal to 1/2 the measure of arc DF. And we know the measure of arc DF is 90. So it's going to be 1/2 times 90. It's equal to 45 degrees. And if you go ahead and take that theorem and you flip it over here, we can go ahead and solve some of these problems using that theorem, like this one here, right? So we're supposed to find the measure of the arc, and we have the equation. The equation is that the measure of ABC is equal to 1/2 the measure of AC. Right, so we can create our equation and solve for arc, measure of arc AC. All right, let's go ahead and look at the second part here. Angles of inscribed polygons. An inscribed polygon is one whose sides are chords of a circle. Inscribed, polygons, and whose vertices are points on the circle. Inscribed polygons have several properties. So if we look at the circle here, we can see the inscribed polygon is made up of chords on the circle. Right? AB is a chord, BC is a chord, CD is a chord, and AD is a chord. And so all of their endpoints lie on the circle R. So polygon ABCD is an inscribed polygon. And so here are some of the properties. An inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So an inscribed angle intercepts a diameter or semicircle. Okay, so if we had this chord here AB and this chord here AD, like we do, this property here tells us that angle BAD is a right angle. It's 90 degrees. And it's if and only if. So that means if we're given that the angle made by the chords is 90 degrees, then the hypotenuse here is the diameter. Okay. So a second property is if a quadrilateral is inscribed in a circle, like we have here, it's 4 sides, 1, 2, 3, 4, it's quadrilateral, then its opposite angles are supplementary. So let's go ahead and write this out. Angle BAD and angle BCD are sup. Right, those are opposite angles here. And also angle ABC and angle ADBC are sup. right? So the opposite angles of the inscribed polygon are supplementary. Okay, so let's go ahead and use those properties to solve this example problem here. We're supposed to find the measure of angle K. And what do we have? We are given the length of chord LM, and we're also given the measure of angle LKM. And we're also given that these two chords are congruent. If the chords are congruent, that means these sides are congruent. Okie dokie. So what do we have here? Okay, no. Oh, actually, I think that this is actually reading that angle KLM is equal to this expression, number of degrees. And we know that KLM is congruent with KML because we have the isosceles triangle theorem. Right, we got the two sides of the triangle congruent, so the opposite angles are also congruent. So what can we do here? Yeah, we can create an equation, because if we have KLM is equal to that means KML is also equal to that expression, and we have angle LKM is equal to this expression. Those all added together via the triangle angle sum theorem is equal to 180 degrees. So let's go ahead and do that. We have 5x plus 5 plus 3x plus 5, plus 3x plus 5, I don't know why I put that parentheses there, is equal to 180. So the angle 1 plus angle 2 plus angle 3 is equal to 180. Triangle angle sum theorem. We'll combine all our like terms. So we got 6, 11x plus 15 is equal to 180. We'll subtract the 15 from both sides. We get 11x is equal to 165. Oh no, x is equal to some strange number here. Let's see if I can get a calculator. Okie dokie, so 165, 165 divided by 11, 165 divided by 11 is equal to 15. Ooh, nice. Okay, so if we have x is equal to 11 and we're trying to find the measure of angle K, that's LKM, we just plug in, right? So measure of angle K is equal to 5 times 15 plus 5. So this is going to be 75 plus 5 is going to equal to 80 degrees. And we're done. Alright, so in this chapter, a lot of the theorems and properties of triangles and quadrilaterals and parallel lines and perpendicular lines are all coming together to help us to solve these problems. So if you need to, go ahead and go back and review some of these concepts so that you're better prepared to solve these problems over here. Right? So let's go ahead and use our properties of inscribed angles and also properties of inscribed polygons to solve these problems, and I'll go over them in the next video.